Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. I'm going to start by writing out all the outcomes. So I'm going to start with trout. So for trout, as a main, I could have had biscuits for dessert. Trout as a main, I could have had cheesecake for dessert. Trout as a main, I could have pancakes as a dessert. Then I'm going to move on to a curry for main. So for curry for main, I could have had biscuits, could have had cheesecake, and I could have had pancakes. Now, to work out the probability, it's the amount of successful outcomes over the total amount of outcomes. So successful for this is a curry and pancakes. So curry and pancakes is a successful outcome, so it's just 1. The total amount are 1, 2, 3, 4, 5, 6. So the chance of me picking at random a curry and pancakes is 1 over 6. The first thing we need to do is work out what angle CBD is. So we're looking for angle CBD, and that's going to be 180 take away 170. And the reason being is it's angles on straight line. Angles on a straight line add up to 180. So that's going to be 10 degrees. So this will be 10 degrees. We then need to find out what angle CDB is. And this is obviously going to be 10 degrees as well because it's angles in an isosceles. So this will be 10 degrees, and the reason will be that it's an isosceles triangle. And to find out what x is going to be, it's going to be 180 subtract 10 plus 10. And the reason for that is it's angles in a triangle add up to 180. So that's going to be 160 degrees. Make sure you state your reasons for every step of the working out, because there's normally quite a few marks for the reasons. We've got first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911. And divide it by the 71 to find out what one part is worth. How many students are in one part? One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts, with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. So we have a set of vertically opposite angles here and here. And we're going to start with those because we have to find out what m is before we can work out what x is. And vertically opposite angles are always equal, so we've got 13m plus 39 is going to equal 2m plus 149. And we're going to get our lines in there because we're going to solve this. And to solve this, we first of all take away the smaller amount of m, because we've got m's on both sides. We can't really cope with that when we're solving. And so we've got a 13m and a 2m, so we're going to remove the 2m. We're going to take that away from both sides to start off, and so we're left with 11m plus 39, and we've just got the 149 on the right hand side. Next we're going to remove the number, so take away 39 from both sides, and we've got 11m is equal to 110, and then we're going to divide both sides by 11 to find out what m is. So m therefore equals 10. So we know if m equals 10, we can then work out x, and the way we can do that is the fact that this one and this one are both on a straight line, so they are both on this straight line here. So we know that they've got to add up to 180. So let's write that down. 13m plus 39 plus x is equal to 180 degrees, or I don't normally put that in for the working out, I always put that in for the answer. So we can solve this, or well, first of all, we know what m is, so it'd be 13 times n, which is 130, and then we can solve this. So let's get my solving lines in. And so that's going to be 169 plus x equals 180, and we're going to just take that away from both sides, the 169. So we've got x equals 11. So the value of x will be 11 degrees. We need to first of all work out the theoretical probability. And to do that, we do the successful outcomes over the total number of outcomes. So here we're asked, it lands on a red is successful, so that's going to be 15 over the total amounts. That would be 40 plus 30 plus 15, which is 85. Okay, now to find the expected amount, it's just the theoretical probability, which is 15 over 85, times the amount of trials, where it says it's spun 500 times. We just go times it by 500. And we get the answer of 88.235, blah, blah, blah. And we're always going to round that down. Okay, so if it's 88.9, we're always going to round it down to 88. Only when it gets to 89 do we write 89. So our answer is that we're expecting roughly 88. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19. That means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy, and when I do that I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.6 0.76 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%, or actually it would be 21%, because this would round it up, so 21%. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them. So 10 times 10t, 10 times 10 is 100. So it'd be 100t. 10 times 4 is 40. So our answer will be 100t plus 40. To prove triangle congruence, you're going to have one of four answers. You're either going to have RHS, SSS, angle, angle, side, or angle, side, angle, and the last one, side, angle, side. So those are our options. So we've got to figure out what we have in this question. Well, we have a right angle, so an angle or right angle. We've got a side, which is actually the hypotenuse, because we know the hypotenuse is opposite the right angle. And then we just have another side. Now, it's not going to be SSS because we don't have three sides. We do have a side and an angle and a side, but the two sides are not next to the angle, so it's not going to be that one. And we don't have two angles, so it's not going to be this one. So the last one is RHS, which is right angle, which we have, hypotenuse, which we have, and side. To find average speed, we do the total distance and we divide it by the total time. Now, in this question, we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to two decimal places will be 5.40. Whenever you have a one-digit number or a one decimal place number, but you're asked to round it to two decimal places, you should really put a 0 on the end, which is what we've done. So we're told that from 14 people who liked football, so we've got 14 people here who said yes, they do like football. So we can fill up the 14 here. Now, we're told we started with 31. Therefore, if 14 liked football, then 17 must have not liked it. Carrying on the sentence, it says 4 like rugby. So 4 of those liked rugby. And we had 14 to start off with down this strand. And so that must mean that we've got 10 who don't like rugby. So of those 14, 4 liked rugby, so therefore 10 must have not liked rugby. But what about the bottom section, this part here? We've got 17 who didn't like football. Well, it says from the people who did not like football, 6 liked rugby. So we've got 6 there, and that must mean that we've got 11 who did not like rugby. To find the exterior angle, of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. So this question says that Adrian, Ben and Charlie have some sweets and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So to answer this question, we've got to first of all work out what transformation it's going to be. And it hasn't changed size, it has changed its way up, and it's obviously going to have been rotated. There's going to be a rotation. And for a rotation, we need to know the angle which it's rotated and where the centre of rotation is. Well, it's obviously gone 90 degrees, it's gone a quarter turn, so it's 90 degrees, and it's gone that way, and so that's the same way as a clock goes, so that's a clockwise. And we need to find the centre of rotation, so we need to find out where the centre of the rotation is. So the way of doing that is just trace out the shape you've got. So trace out A. And it's going to look something like this. And trace it out. Just connect those bottom bits a little bit better. And trace it out, and what you've got to do is you've got to find out where on this page you put your pencil when you rotate it. And so you're just going to rotate it with putting your pencil somewhere. So you want to end up with it looking like this on the tracing paper, and you, just with a bit of trial and error, you'll realize that you can put your pencil here. So your pencil will go at 2, 2 to get from A to B. So our center of rotation is going to be 2, 2. To find the density of this wooden block, we're going to have to first of all find out what the volume of the block is. And volume is the cross-sectional area times by the length. And the reason why it's that is it's a prism, and all prisms you just find the area of the cross-section and we times it by the length. So what is the shape of the cross-section? Well, the cross-section is a triangle, and the cross-section is this part here. I just quickly colour it in. And so we're just finding the area of that triangle, so half base times height, and we're going to times it by the length, and the length is how 3D the prism is. So the base is 3, the height is 14, and the length is 5, and when you do that you get 105 centimeters cubed. Right, now we need to find out what the density is, and the formula for density is mass divided by volume. The mass is given to us in the question is 246. The volume we've just worked out, is 105. And so you do 246 divided by 105, and you get 2.342 blah blah blah. And then we round that to 2 decimal places, which it says in the question to do, and that would be 2.34 grams per centimeters cubed. There is quite an easy way of doing this question, but I'm going to show you the long way, and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. To convert from meters to centimeters, we times by 100. But here we're asked to convert between meters cubed and centimeters cubed. So we times it by 100 per dimension. Meters cubed and centimeters cubed is volume, which is 3 dimensions. So what we do is we times it by 100 3 times, times 100, times 100, times 100, or times by 100 cubed. So we get our amount, 0.15, times it by 100 cubed, and that will give us 150,000. So our answer is 150,000 centimeters cubed. So first thing to realize is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 1497069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same. So we're going to keep that as the volume, 1497069 pi. But we want the radius to change. So instead of the radius being 89, we want the radius to be 103. So times 103 squared. And we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. Actually, we don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that would be 141.11. So there are 2 outcomes that it will rain once in the next 2 days, and that will be rain and not rain, and not rain and rain. So to work out the probability, it will rain on Monday and then not rain on Tuesday. What you're going to do is just multiply 6 over 20 by the 2 over 7. So 6 over 20 times 2 over 7. And that will give us 12 over 140. And to work out the probability, it will not rain on Monday and rain on the Tuesday. We're just going to multiply the 14 over 20 by the 5 over 7, and so that would be 14 over 20 times 5 over 7, and that will give us 70 over 140. Now we're looking for the probability it will rain and not rain, or not rain and rain. The word or in probability means add. So we're going to get that 12 over 140 and add it to the 70 over 140, and that will give us 82 over 140, and then we can cancel that down to 41 over 70. So we've got to first of all understand what standard form is, and standard form is a number that is between 1 and 10 but not including 10 times 10 to the power of another number. So to find out what the numbers are going to be for our standard form, we're going to just write down the decimal first, so 0.098. And we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8, and we're ignoring the zeros to the left-hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we had to do. So it would be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of -2. It's sometimes easier in these questions to view these triangles as 2 separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle, and kind of move that to the side. So we can see we've got 2 triangles here. We've got a big triangle and a small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the 2 triangles are similar because the sides here we assume are we know they are parallel because they are right angles, and they share an angle here, which we can just label as A. and so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20, and then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. To find an error interval, what we need to do is find the smallest and largest that a number can be. So I start by just drawing a quick number line, and we put our number in the middle, which is 89.6. Now we're looking to the nearest tenth, so what I'm going to do is I'm going to write down the next number down and the next number up in tenths. So the next number down would be 89.5, the next number up would be 89.7. Now the bounds, the upper and lower bound, the maximum and minimum number it could be before rounding, are going to be at the halfway points. So here and here. And so all we need to do is work out what those numbers are. So halfway between 89.5 and 89.6 is 89.55. And halfway between 89.6 and 89.7 is 89.65. So those are going to be our lower and upper bounds. But how do we show it as an error interval? Well, we put t in the middle because it tells us that t is representing the time, and we show it with inequalities. Now, the number can be 89.55, but it can't be 89.65 because that would round to 89.7. So we say everything that's less than but not equal to. We've got to first of all work out how many jumps there is between our shape and the centre of enlargement. So I'm going to pick a point at the top of our shape, and we can see that there are 2 jumps to the left, and 1, 2, 3, 4, 5, 6. So we've got to go 2 and then 6. And the reason we do this is we're looking at a scale factor of -2, which means we're going to go through the centre of enlargement. And what that means is we're going to do 2 left and 6 down another 2 times because it's -2. So we're going to go 1 and 2, 1, 2, 3, 4, 5, 6. And that would be a scale factor of -1 if I plotted that point. We're at -2, so we're going to go another 2, 1, 2, and another 6. 1, 2, 3, 4, 5, 6. So our new coordinate is down there. And we can go ahead and do this for the other 3 coordinates. I'm going to do it for the bottom left point. So we go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So the coordinate's going to be there. Now I can do it for the third one, or I can just kind of work out where it's going to be. Because if I draw in this shape, well, we've got the 2 coordinates here. So it's kind of on the y-axis. You can't really see it too well. But we know the other one is going to be 4 to the left, because on our original image it's 2 to the right. And so a scale factor of -2 would be, instead of 2 to the right, if you negate that, it's going to be left, and if you times it by 2, it's going to be 4. And let's just draw in our last part of it, and that's going to be our new triangle there. And it says to label it B, so we're just going to put B on it. We're going to write this out again just to give us a bit more space. So we've got S equals 4 minus 13t over t minus 5. I'm going to get our lines in. Okay, So the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with s brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be either way around, so I could have 5s plus 4 over 13 plus s, or anything like that. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that. And so this is going to be 44 degrees here. So angle BFD equals 44 degrees. And the reason you need to give is the alternate segment theorem. And you have to use those words, otherwise you won't get the marks. Now, next I notice that we've got a set of parallel lines here, and we've got a line going through them, and so the 44 degrees there is going to be equal to this one here, and so this is going to be 44 degrees. So we say angle FDE equals 44 degrees, and the reason this time is alternate angles, put the E in, angles, and again you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here and here, and the bottom 2 angles in an isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here, so angle EFD is also 44 degrees, and again we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44, and the reason is angles in a triangle add up to 180 degrees, and so 180 take away the 44 plus the 44 is 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all four corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92. And again, we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. So there are two things with this question. There's the negative power and there's the half. And we're going to deal with them separately. So to deal with a negative power, all you need to do is put the whole thing over 1, or 1 over the whole thing, I should say. And it's nothing more complicated than that. We just copy the same thing again, but this time instead of it being negative a half, it's just to the power of a half. So that's dealt with the negative. Now to the power of a half means square root. So whenever you see anything to the power of a half, it just means square root. So let's deal with the 16 and the x to the power of 16 separately. Now with the 16, we're going to square root it, because to the power of a half just means square root. So square root of 16 is 4. Now with the x to the power of 16, there is another rule in indices that say if you've got a power on the inside and a power of the outside, you just multiply them together. So 16 times a half is 8. So the answer will be 1 over 4x to the power of 8. I'm going to start off by labelling the triangle, and so we've got capital A here, capital B, capital C, and lowercase a, lowercase b, and lowercase c. It doesn't actually matter which way around B and C are, but capital A is always the angle that we're given. So we've got to work out whether we're using cosine rule, sine rule, or something else. Well, here we're given 3 lengths. Well, actually one of them is unknown, but there's 3 lengths involved and an angle, so that's definitely going to be cosine rule. So we're going to write out the cosine rule for when we've got a length, which is the one that starts with a squared. So it's a squared equals b squared plus c squared minus 2bc cos a. And let's fill in the numbers we've got. So that's going to be 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 22. And when you type that into the calculator, you get 6.184 blah blah blah. But that's what a squared is. So what we need to do now is just quickly solve that by square rooting both sides. And so we get a equals 2.486 blah blah blah. It says it wants its 2 decimal places, so that's going to be 2.49. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x, so half of the 10 would be 5, close bracket, squared. Now I'm going to leave that half done, because down here I'm just going to, or across here I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. I'm going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the two lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So the first thing I'm going to do is I'm going to put my lines in, because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side, because that gets rid of the denominator. And it would be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I am going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, was it 56,100? I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870, and we're going to take that away from both sides. So take away 1870x from both sides, and that will leave 5100x on the left hand side, and then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So A is 17. So we're told to complete the square, so we're just going to get this equation here and just complete the square for it. So the first thing I'm going to do is remove the coefficient of the x squared. So we want just x squared and so on. So I'm just going to make a set of brackets, and we're going to factorise it out of the x squared and the minus 24x, so that would be minus 8x. Then we've got the takeaway 15. Next, I'm going to complete the square, so I'm going to do this in a different colour just so we can see what's happening. And to do this, we have a bracket with an x minus half of the coefficient of the x, so that'd be 4 squared. Now if we expand that, we get x squared, brilliant, minus 8x, fantastic, and then we have a plus 16, so we need to remove the 16, so we're going to take away the 16. Next we're going to expand the bracket with the 3 in, so we're going to have 3 brackets x minus 4 squared, or close bracket squared, minus 48, minus 15, and then we're just going to tidy that up by adding the numbers together, so that would be minus 63. On our graph, we're going to draw the graph of y equals 3x squared. Okay, simple. And we don't need to, it's only a sketch, so we don't need to worry about exact values, but we do know, the most important thing is we know it goes through the origin, so it hits here at 0, 0. That's the important thing, okay? Because we know that if we called that f of x, then the situation we've got here, well, it's going to be f of x minus 4, okay, because we've got the minus 4 there. So that means it will move to the right 4. Okay, and it will also, we've got to worry about that minus 63 as well. And if we had f of x minus 63, we know it goes down 63. So in total, we have f of x minus 4 take away 63. That's what we have in total. So we're moving just 4 to the right and then 63 down. So instead of 0, 0, our minimum point will be at 4 minus 63. You can see there's a plus 2 inside the function. Plus 2 inside the function actually does the inverse of what you think it will do. You would think it would move the graph twice to the right, because all the things inside the function are normally are to do with the x plane, so they're going to move it left or right, or stretch it out left or right. But actually with a plus 2 you go left 2. So if we pick a coordinate, say this one here, that will actually be over here, and this one here will actually be here, and this one here on our graph will actually be here, and we can just have a look at each of the points and we'll see a graph will probably go off somewhere there, and then we count twice for this one as well and probably go off somewhere there. So when we draw the graph, in fact we've got this one down here, when we draw the graph in, the graph will look exactly the same, but it will move to the left 2 squares. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.